Have you ever heard of a star so massive that not even light can escape it? Most of us would immediately think of black holes, a concept made famous by Albert Einstein in the 20th century. But what if I told you that the idea of these cosmic giants was first proposed over 200 years earlier by a man whose name has been largely lost to history? This is the story of John Michell, the forgotten father of black holes. Our journey begins in the quiet English countryside of the 18th century. Here, a young John Michell spent his childhood not just playing in nature, but devouring books, his mind ignited by the wonders of the world around him. This insatiable curiosity eventually led him to the prestigious halls of Cambridge University. Imagine the scene: old classrooms filled with eager young scholars, the air thick with the scent of chalk dust and aged wood, as Michell absorbed the knowledge of the giants who came before him. He was particularly drawn to the mysteries of the night sky. In an era lit by candlelight, he would spend countless hours poring over astronomy books and ancient manuscripts, his quill scratching away as he tried to unravel the secrets of the cosmos. He wasn't just a reader, he was a doer. His study was a laboratory filled with ingenious instruments, telescopes, and mechanical devices, many of which he designed and built himself to test the very fabric of the universe. Michell was deeply immersed in the world of Newtonian physics. Sir Isaac Newton's laws of gravity, published less than a century earlier, had revolutionized science. But Michell dared to push these ideas to their absolute limit. Surrounded by old paper and complex diagrams in his dimly lit study, he began to write down his groundbreaking theories. He asked a simple, yet profound question: if gravity affects everything with mass, does it also affect light? In his mind's eye, he sketched out a revolutionary concept. He called them dark stars. On celestial maps, among the hand-drawn constellations, he envisioned stars so dense and with such a powerful gravitational pull that their own light would be trapped, unable to escape into the cosmos. He meticulously explained how light, according to Newton's theories, should behave like a particle, and therefore be subject to gravity. On chalkboards, he drew diagrams illustrating how the pull of a massive object could slow down and eventually capture a beam of light. It was a staggering intellectual leap. In 1783, Michell published his ideas in a paper to the Royal Society of London. Picture the scene: a gathering of the era's greatest scientific minds, listening as this relatively unknown clergyman and natural philosopher from the countryside presented a concept that was almost too strange to believe. He proposed that if a star were 500 times the diameter of our Sun, but had the same density, its escape velocity, the speed needed to break free from its gravity, would exceed the speed of light itself. Consequently, the star would be invisible to us, a dark star hidden in the celestial tapestry. This was, in essence, the very first description of a black hole. He even suggested how we might detect these invisible objects by looking for star systems where a visible star appears to be orbiting an unseen, massive companion. This is the exact same method astronomers use today to find black holes. Yet, despite its brilliance, Michell's theory was largely ignored. His papers were read, discussed briefly, and then filed away. Perhaps the idea was just too far ahead of its time. His peers struggled to comprehend such a bizarre cosmic entity, and without the means to prove its existence, the theory of dark stars faded into obscurity. You can almost feel his frustration: scattered papers on a desk, the lone flicker of a candle reflecting in his eyes as he looked up at the same stars that held the secrets he so desperately wanted to share. For over a century, Michell's incredible insight remained buried in academic archives. It wasn't until the 20th century, with the arrival of Albert Einstein and his theory of general relativity, that the idea was reborn. Einstein's equations provided a new, more robust framework for understanding gravity, predicting the existence of singularities in space-time where gravity is infinitely strong, what we now call black holes. When you compare the two, the similarities are astonishing. A visual overlay shows Michell's 18th century sketch of a dark star, a simple yet powerful concept, morphing into the complex, warped space-time diagrams of modern physics. Michell, working with quill, ink, and Newtonian mechanics, had arrived at a conclusion remarkably similar to what Einstein would discover with advanced mathematics and a completely new understanding of gravity. He was a man thinking in four dimensions, to centuries early. Today, modern physicists and historians of science are finally giving John Michell the credit he deserves. In research papers and books, his name is acknowledged as the true originator of the black hole concept. His letters and handwritten notes, preserved in historical archives, reveal a mind of incredible depth and creativity, a natural philosopher who was also a pioneer in seismology, magnetism, and statistics. So, the next time you gaze up at the night sky, mesmerized by the infinite sea of stars, remember John Michell. Remember the quiet country boy who dared to imagine the impossible. His telescopes and instruments, now displayed in museums, are a tribute to a forgotten genius. He may not have had the tools to prove his theories, but his legacy is written in the stars themselves, in the very black holes that he first envisioned, shining darkly in the vastness of space. He is the forgotten father of black holes, a testament to the enduring power of human curiosity. Thanks for watching. If you found this story as fascinating as I did, be sure to like this video and subscribe for more journeys into the history of science. See you next time.